So this is the first one. We're able to express it in the partial fractions of variables. But right now we are going to solve for the values of a and b. So how do we do that? So first, what I'm going to do is that I'm going to push these things up, right? They are very huge. So let me, now that we have the actual question, let me just basically delete these ones and send these ones up, so we know what we are doing. Okay, so let me separate this into two. What you do is that you multiply both sides. I don't think this whole thing will help. So you multiply both sides by the numerators, right? So you use this particular one, to multiply every term here. So what you do is you're going to have 3x plus 1 equals to, so we have, if you have this to multiply a, so it's going to have x plus 1 multiplying x minus 2, right? To multiply a over x plus 1 plus this one, to you multiply, use that denominator, x plus 1 multiplying x minus 2 multiplying b over x minus 2. What I did is that I took this denominator here to multiply. It's as if I'm doing cross multiplication. I use it to multiply this term, and I use it to multiply this term. So this denominator will go and multiply the term here and the term here. So that denominator is what I'm having here to multiply the term here, plus that denominator again to multiply the other term. Okay, so now at this stage, what we do is that we keep this one, 3x plus 1 equals to, so this x plus 1 will simplify this x plus 1 factor. So you'll be left with a multiplying x minus 2. That's what we'll be left with. Plus over here, x minus 2 will also simplify this x minus 2 factor. So you'll be left with b multiplying x plus 1. So that's what we have for now. So if that is done, I can clean this side, right, and push this one up for you. So let me do it like this. Send everything up so you can continue peacefully. Okay, so the next one is, after doing that, we now have expressions such a way that they are like identities that we solve, right? So what you do is that you try to use the cover up rule. So you can expand or you can use the cover up rule. So in this case, I'm going to use the cover up rule. So for me to cover up this one, I need to make this one 0. I need to select the values when x is equal to -1, because when x is -1, this will become -1 plus 1. This will become 0, and everything here will be 0. So I will just have 3 to multiply -1 plus 1. That's why we took time to do identities, cover up rule, and expansion rule. A multiplying -1 minus 2. This one will give us -3 plus 1 equals to -3a. So because -1 minus 2 is -3, and this will give us -2 equals to -3a. So you can see that a equals to 3 over 2. This is value for a. So we need to find the value for b by covering up a. We are going to cover up a now. So if I want to cover up a, so I know the value for a, so I'm going to change a new value. I'm using the same board so that you can understand, right? You can follow up well on the same page, not giving you different tables. So, okay, yeah, so we have this. So next one is when x is equal to the 2. When x is 2, this one will be 2 minus 2, that will be 0, and all these will be 0, right? And b will be there. So I will have 3 to multiply 2 plus 1 equals to b to multiply 2 plus 1 over here. That will be 6 plus 1 equals to 3b. So you can see that this is 7 is equal to 3b, and b equals to 7 over 3. Basically, that's what we have. So this is the value for b. So we are going to rewrite the entire expression again. So if you write the entire expression again, you can see that where you have a, you put the values of a over there. So this one, so our final answer 3x plus 1 all over x plus 1 multiplying x minus 2 is equal to a. A is what? 3 over 2, right? 3 over 2 to multiply the factor s plus 1 plus b. The value of b is 7 over 3 divided by the factor x minus 2. So this is the final answer. Or if you want to go more, that one is correct. What you have already is correct. But then if you want to make it more professional, we come 3 over 2 multiplying x plus 1 plus 7 over 3 multiplying x minus 2. So this is the partial fraction of that. You can see that we have something whole like this move together into separate functions. Okay, so let's look at the next example. For this example too, we are going to use this to multiply this, right? So I'm going to have 5 will be equal to, when you do the simplification, you will finally get a multiplying x plus 3 plus b multiplying x minus 1. So now you say when x is equal to 1, if x is equal to 1, that will be 1 minus 1, which will be 0. So this one will be covered up. If this one is covered up, I will just have 5 will be equal to a into bracket 1 plus 3. That will be 5 equals to 4a. So which means that a is equal to 5 over 4. So this is the value for a. The value for b, I need to cover up b. This is the value for a. So for me to cover up a, I need to make this x to be negative 3. So let me say when x is equal to negative 3, right? When x is equal to negative, this guy will be gone. I'll have 5 equals to b multiplying negative 3 minus 1. That will mean that 5 will be equal to negative 4b. So b is equal to negative 5 over 4. So b is equal to negative 5 over 4 and a is positive 5 over 4. So what you do is that you just go back. Where you see a, you put the value there. So a was 5 over 4 and b is negative 5 over 4. So you can stop there or make it more professional by sending the 4 down and then sending this 4 down, making this one negative. Okay, let's look at this one. So we had time to explain this one very well, right? And this one, we have to do long division first. So for this long division, I'm going to leave it when we are doing the overall partial fractions of